Hey guys, welcome to another video. So today, another nice question in the nice question series. Today's question comes from the advanced syllabus from the Blacktown Boys 2024 trial papers. In fact, it's the last question in the exam. It's a question in the topic of calculus optimization, so maxima and minima. So look, there's quite a lot of marks, 8 marks at play here. It's a nice question. Let's check it out. Now, actually, before I dive in, as always, please, if you like the content, please subscribe to the channel, like the video, and tell your friends. All right, guys, let's dive right in. So, Blacktown Boys. So we have a question here. I love these questions where it's basically geometric shapes within geometric shapes. Let's have a look at this. So, rectangular pyramid is placed in a bowl, right, of depth D. I can see that in the diagram, right, in which there is of a sphere and centers O and radius is R. Okay, cool. Apex of a pyramid has O as well. Okay, vertices, base A, B, C, D, lines on both inner surface. I can see that. The perpendicular from O, okay, midpoint M, okay. Let X equals to OM, is that on the diagram? Yep, that's there. CB is B, yep, that's there. And AB is 3B, okay, cool. All right, so everything in the paragraph is in the diagram, so I can just look at the diagram. So part A, show, all right, dB was dB, dB is the diagonal, okay, yep. Show that the volume, okay. Now that's probably the equation that I then differentiate, so maximize, okay. Find the value of X, maximize, and then what's part D about? If the depth of the bowl is up, explain why the maximum volume C cannot be achieved, and then find greatest. Okay, cool. All right, let's dive right in, guys. Hello. dB. So I want to prove this side here equals some sort of relationship with R squared. Looks like Pythagoras, right? Looks like. Okay, you know what? I can see it there. I'll find MN, so MB, and then double it, right? That's really the right angle triangle at play here. So I can just say in triangle, so OMB. Yeah, I got MB squared equals to OB squared minus OM squared, Pythagoras, right, which equals to R squared minus X squared. You go therefore MB equals to square root of R squared minus X squared. Don't need plus minus because it's a length, right? Therefore, well, dB equals to 2 times MB. Therefore, dB equals to 2 times square root R squared minus X squared. Easy as that. Yeah, 1 mark. All right, but 2 marks got to prove. Now, I always say this to my students, right? If you couldn't do part B and prove that volume, you can still differentiate that and basically get the 3 marks in part C, right? Don't just stop when you freeze in part B, right? So, part B. So, volume. Now, I know that volume of a pyramid is a third area of the base times H, right? Yeah, times H. Yeah. Now, in this case, the height is X, right? So let me just highlight that, right? So maybe I'll go, use pink. Yep. So area of the base is like, it's a rectangle, right? That's just 3B times B, which is 3B squared. And height, I can see it there, it's X. So therefore, the volume is going to be a third times 3. That's a third times 3. I think that goes well. So it's BX. Just BX squared. So B squared X. Let me just check that. Perfect. Now, I don't want B, right? B is not in the thing that I want to prove. So I need to find something, right, where I make B squared the subject, right, so, in terms of X. So what can I use? Now, let's have a look. Right, chances I'm going to somehow, now the question has R's in there as well. So, so maybe link, I'm thinking Pythagoras somehow. Is there a R that links in? Yeah, it looks like maybe that diagonal. So I already used that, right? DB. So I want DB in there somewhere. So maybe I'll just link this. this Pythagoras here, right? Yeah, because I already have an expression for dB, and so maybe I can link dB with the other signs, and then I get something, right, in terms of b squared only. Perfect. So maybe I'll go in triangle, what's that called? DCB. Yeah, I got dB squared equals to DC squared plus CB squared. All right, so what I'm going to do, I'm going to do double sub, right? I'm going to sub this into here, right? And then DC and CB I can see from the diagram, right? So that's like 2 square root r squared minus x squared. And that equals to DC squared. I think DC is a long one, right? Yep, 3b all squared. B all squared plus b squared. Now, what am I trying to do? I'm trying to make b squared the subject, right? So hopefully I can do that. Let's have a look. So that's the square there. So that becomes 4. And the square root goes away. It becomes 9b, so that's 10b squared. Therefore, b squared is 4, oops, not root, r squared minus x squared on 10. Oops. Yeah, on 10, which makes it 2 and 5. I think that's what I want, right? Yeah, 2 and 5, perfect. Therefore, b squared is 2 r squared minus x squared on 5, which is great. So that's exactly what I need, right, to sub back into here, right? So therefore, is it times x? Yep, perfect. Well, that's what I need. Therefore, I've got it that b, also not b, volume equals to 2/5. The x is out there, and r squared minus x squared, which is exactly what they want. Have a quick look. Perfect. Guys, that's part A, part B, right? Now, so then the classic sort of scenario now where I have the equation that I need to differentiate, and I'll differentiate it, right? And then try to solve for x, and then test for max min, yeah? Let's do that. So, let's see. So volume equals to 2/5 x, and r squared, r is a constant, right? So now, before you differentiate this with the product rule, a smart thing to do, maybe expand, right? Use a bit of rainbows, expand that, just makes life a lot easier. Sorry, when I try to differentiate that. Right? Next. Yeah, so then dv over dx, bring down, no, not even bring down the 2, right? Because I'm differentiating with respect to x, and that's that. Bring down the 3, is that right? Let me just check. Bring down the 3, yeah? So it becomes like 6 on x squared, right? And that's my derivative. Yeah, that's my derivative, right? Now, I'm gonna set that to 0 so I can solve, right? So then 6 on 5x squared equals to 2 on 5r squared, times it all by 5 divided by 6, because I think it's like r squared on 3. So therefore, now x is a length, right? So I don't care about the negative case, right? So x equals 2 r on root 3. All right. Once you get there, you need to test for max min now. Do I want max or min? Hope that maximizes a volume. Okay, cool. So test for max or min, right? Where maybe set up a table method, right? There's x and this is dVdr, right? You sub it into the derivative. So guys, just be absolutely clear. I'm subbing this into, or subbing these values here. I'm subbing all those into that box, right? Yeah. Now I know r on root 3 here will give me 0. That's 1 on root 3. So maybe I'll go, I wonder if I can sub in 0. Yeah, mathematically I can, right? And then sub in r here, right? There's no other turning point, so that should work. Oh, it's negative, but that's way too negative. Right? So if I sub in 0 into there, I get positive 2 on 5 r squared. If I sub r into there, now this number here is basically 2 on 5 r squared minus 6 on 5 squared. Guys, what's that? Minus 4 on 5 r squared, right? Minus 4 5 r squared, which is clearly negative, which shows a change in gradient. So it goes like positive gradient, flat, negative. Therefore, maximum volume when x equals to r on root 3. Now, is that what I want? Did I actually find the value of x? Okay, cool. I'm done, guys. Yeah, everything's going not too bad, right? Let's have a look at the next one. Is a little bit harder. So make this makes this into a very nice question. Let's have a look. Click the wrong button. If the depth of the bowl, so depth of the bowl is r on 3. So well, that's d, right? Yeah, that's d. That's the depth of the bowl. Okay. Explain why the maximum. Yeah. Let's see. Explain why the maximum volume from C cannot be achieved if that's D. Okay, now in this diagram, this is actually, let me copy it to another tab. I'm just going to remove everything and all the colors in the diagram. Just want to isolate it, right? Okay, just want to show you something. Can you see, right, in the diagram, there is a relationship, right, between the radius, right, and X and D, right? Now, with X and D, if you think about the radius, right, if I sort of swing the radius down to the bottom over here, right, for this diagram to work, the radius must be smaller than the sum of the two pinks. Because if the two pinks are bigger than, so if the two pinks are smaller than R, then you won't create the shape, right? R has to be, right, bigger. Sorry, let me say it again. The sum of the pinks has to be bigger than R, right? So let me write that down actually. So D. Yeah. Sum of the pinks, so D plus X has to be bigger than R. Has to be, right? If you think about it, right now it looks bigger, right? Yeah. Even when the blue swings around, has to be bigger. If the blue, so right now, let me get this diagram right. So the pink is bigger than the blue. If the blue is bigger than the pink, then the pinks won't never connect, right? And you'll never create this shape. The pyramid will be outside of the bowl, so to speak, right? So from the diagram, right? From diagram. Yep. Now, in this case, if the depth is given to be, was it R on 3? Yeah, sub that in. R on 3 plus X is greater than R, right? And then X, throw that guy over the fence, 2R on 3, right? Now that's important. So basically, if I wanted D to equal to R on 3, then X has to be greater than or equal to 2R on 3. Now, in this case, right, I want to know, so the question says two things. Explain why the maximum volume cannot be achieved, right? Since max volume is when R equals to, sorry, X equals to, when X equals to R on root 3. R on root 3 is smaller than this, right? Therefore, max, yeah, R on root 3, maybe I'll go, which is less than 2R on 3, right? It has to be, because 1 on root 3 is smaller than 2/3, right? Yeah. Therefore, max volume cannot be achieved when D equals to R on 3. Right, that's the first part. That's the first mark. And then it goes, hence find the greatest volume now possible, right? Greatest volume now possible. Now, guys, so then we come back up to here. How do I find the greatest volume possible if X is greater than or equal to that? If I come back over here, right? Since dv dx equals 2. Now, what did I get that to be? I'm going to go back to the other one, copy and paste it. What's my derivative? Got it over here. Yep, yeah. Just copy that, I'll delete the junk that I don't need. Okay. Where is it? Come up here and group that. Okay, I want this. Okay. Since that's my derivative, yeah. Now, what can I say? Since that's my derivative, yeah, when x equals to, now let me sub in the boundary here, right? The 2r on 3, right? Into here. So let me just show you what I'm doing. I'm just subbing this into the derivative just because I want to know, right? Actually, let me sub it and I'll show you what it shows me. It's actually quite important. dv dx equals to 2 on 5 squared minus 6 on 5, 2 on 3 r squared. Right? Now, what is that as a fraction? Sorry, 2 on 5 minus 6 on 5 times, oh, sorry, that's a squared, right? Squared there, not there. Times, that's negative 2 on 15 r squared. Now, when I subbed in 2r on 3 and the derivative is negative, that means, right? Yeah, v is decreasing. If v is decreasing and there's no other turning points, right? No other stationary points. Every value bigger than this value of x, right? If I sub in any value bigger than that, it's always going to be a smaller volume, right? So the maximum volume given this domain, right? The maximum volume is 2r on 3, right? So I can conclude, therefore, yeah, max volume when x equals to 2r on 3. Because, let me say it again. The reason why that makes sense is because at 2r on 3, I've shown that the derivative is negative. So volume is only going to be decreasing as I sub in bigger numbers of v, or bigger numbers of x. Therefore, the biggest volume occurs when x equals to 2r on 3, right? And then I sub that into my volume formula, right? Which is over there. So therefore, can I just move this over here? Therefore, max volume equals 2. I'm going to sub that into 2 on 5, 2r on 3, r squared minus x squared. Let's clean this up. So that's like what? 4r on 15, r squared minus 4r squared on 9. So 1 minus 4 on 9 times 4 on 15. Okay. Which is 4r squared on 27 units cubed. How's that? Guys, so for this question, that's nice because basically you got to start with the premise that the blue has to be smaller than some of the pinks, or the some of the pinks is bigger than blue, right? It has to be. Otherwise, the pyramid sort of detaches away from the bowl, right? Once that's true, you'll show that algebraically x is greater than or equal to 2r on 3, right? Which then says I can't have the maximum volume that I had before because the maximum volume that I had before was smaller than 2r on 3, right? Okay. And then once you got x is greater than or equal to 2r on 3, I showed that if I sub in 2r on 3 into the derivative, it's negative, which means it's decreasing. right? Volume is decreasing. So the maximum volume is when it's 2R and 3. Sub 2R and 3 into the volume formula, and you got it. Guys, what a nice question. Hope you liked it. If you did, please like the video, subscribe to your channel, and tell your friends. Thank you very much.